I'm Josh, and today I will be presenting aluminum, an abundantly cellular metallic resource. Within smartphones, you see aluminum being used in the unibodies, the frames, the shells, and the overall structures of these phones. That can be said for every manufacturer, be that Samsung, HTC, Apple, Microsoft, who now owns Nokia, and other related companies. You also see aluminum being used for the backs and casings, most notably on the recent generation of iPhones. And you also see aluminum used in a couple components. Generally for electronic transmission you see gold and copper used, but aluminum is used within antennas and as heat dissipation devices because mobile phones are essentially miniature computers. Quantities and cost. Aluminum, there's a lot of variation in the aluminum that's used. My Samsung Galaxy S5 comes in at a 150.6 gram mass. Assuming a conservative 20% of the phone being made of aluminum, that would be about 30.12 grams of aluminum in my phone alone. At 72 cents per pound, there's approximately 7 cents worth of aluminum per device. Now, while that may not seem like a lot, that amount adds up whenever you account for all of the phones in the United States. There's a total of 21,752,207 pounds of aluminum within the United States alone. That doesn't include worldwide. And at that 72 cents per pound, that brings the total value of aluminum in U.S. cell phones to $15,661,589.12. All of that aluminum typically comes from the raw aluminum pellets you can see in the figure that is then refined and customized into whatever specific aluminum alloy or compound the manufacturer wants. Statistics. In the United States, over 17% of our aluminum use is actually imported from other countries. China is currently the biggest exporter in the world. However, this is not actually due to their abundance of natural resources. They are not near the top as far as natural resources in aluminum. That role goes to Australia. But China has really good funding, which allows them to purchase an excessive amount of aluminum from other countries. In the figure, you can see that China in 2011 purchased 45% of their aluminum from other countries, mostly Indonesia. Bauxite is the aluminum ore that is most common. Within bauxite, you can have up to 90% aluminum, but across the entire crust, it's only about a 25% content. And this aluminum and bauxite actually makes up about 8% of the Earth's crust, which means it's really high in content compared to other compounds. The Guardians of the Samsung Galaxy. I made that title based off the fact that my personal phone has a protective layer of aluminum. You can see from the figures disassembled, the unibody of it is actually made of aluminum, and the purpose of that is, one, heat dissipation. It helps the components to alleviate heat, and two, it provides a structure that makes sure the internal components don't get damaged in the event of a light drop or bump. But with all that in mind, there's a lot more ore required than actual aluminum. Just for my phone, to produce that 30.12 grams of aluminum, you need 120.48 grams of bauxite or aluminum ore, which results in a waste of 90.36 grams. So most of the aluminum ore at the 25% is wasted. As a result, you end up with $1,440 worth of aluminum per ton of phones, but we can only make $360 worth of aluminum per ton of ore. So that means to produce a ton of aluminum for phones, there's a lot more than a ton of ore required. The aluminum industry. In the United States alone, we have an average recycling rate of 67% for aluminum. Now, while in most metal recycling industries, the jobs are lower in quality and there are fewer jobs available as opposed to raw mining, this is actually beneficial for the United States because we import so much of our aluminum. Our aluminum recycling creates jobs that we wouldn't have otherwise. Now, this recycling process requires high heat. High heat requires high energy, so there's a lot of pollution and oftentimes an excess release of greenhouse gases in the process of refining and recycling. Now, aluminum, in its naturally occurring state, requires very heavy processing because it's so stable, and that heavy processing means high power and an increased toxicity in the runoffs and ashes. The most interesting fact I learned about aluminum was that it is the third most abundant crust-bound mineral on this Earth, only after oxygen and silicon. And it's the second most abundant metallic mineral, of course, after just silicon. The figure on this slide shows the amounts of the most abundant minerals that we have on Earth. You can see iron is not too far behind with 5%, but aluminum makes up 8% of the Earth's crust. I thought that was a pretty substantial amount, a lot more than I expected. These are the references for my content and the references for the images that I pulled. Thank you.